Have you ever wondered if time travel could be more than just a concept from science fiction? Imagine being able to travel through time, visiting both the distant past and the far future. It sounds like something out of a blockbuster movie, but surprisingly, black holes, some of the universe's most mysterious and powerful objects, could hold the key to making time travel a reality. In this video, we'll explore how black holes are linked to time travel, diving into the science, theories and challenges that come with this fascinating possibility. To understand how black holes could be connected to time travel, we first need to know what black holes are. A black hole is a region of space where gravity is so intense that not even light can escape from it. This phenomenon occurs when a massive star collapses under its own gravity, creating an infinitely dense point known as A at the center. Surrounding the singularity is the boundary beyond which nothing can return, not even light. The key to black holes' connection to time travel lies in their effect on space-time. According to Einstein's theory of general relativity, black holes warp the fabric of space-time around them, creating extreme conditions where the normal laws of physics start to break down. This warping of space-time creates several intriguing possibilities for time travel, especially when we consider time dilation near a black hole. One of the most mind-bending effects of black holes is time dilation. This refers to the phenomenon where time passes at different rates, depending on how close you are to a massive object like a black hole. The closer you get to a black hole, the slower time moves relative to someone far away from the black hole. This is a consequence of space-time being stretched and distorted by the black hole's immense gravity. Imagine you're near a black hole, maybe in a spaceship orbiting it. To you, only a few minutes might pass, but back on Earth, many years could go by. This is what we call. Essentially, time behaves differently near a black hole, and this could allow someone to travel to the future without physically moving anywhere in time. While you can't travel backward to change events in the past, you could experience time passing at a vastly different rate, essentially jumping ahead into the future. Wormholes and time travel. While time dilation allows for travel to the future, what about traveling to the past? This is where wormholes come into play. A wormhole is a theoretical structure that connects two separate points in space and time. Imagine it like a tunnel through space-time, where one end of the tunnel is in your present, and the other end could be in the future or the past. If such a wormhole exists, you could theoretically travel through it and emerge in another time period. Some physicists propose that black holes could act as entrances to wormholes. Theoretical models such as the Einstein-Rosen bridge suggest that black holes could be connected to distant points in space via these shortcuts through space-time. If wormholes were stable and accessible, they might offer a path to time travel. However, there's a significant issue. Wormholes are thought to be highly unstable, and they would collapse before anything or anyone could pass through them. To keep a wormhole open, some theorists believe we would need something called exotic matter, a form of matter with negative energy density. Unfortunately, exotic matter has never been observed, and its existence remains purely hypothetical. Rotating black holes and closed time-like curves. Now let's dive into even more fascinating territory. There's another kind of black hole known as a Kerr black hole, which rotates rapidly. The unique property of rotating black holes is that they might allow for closed time-like curves, or CTCs. A closed time-like curve is essentially a path through space-time that loops back on itself. In theory, this could allow you to travel backward in time, revisiting your past or altering events. These closed time-like curves would exist in the region around the rotating black hole, where space-time itself is twisted by the black hole's rotation. If you could navigate this region, you might be able to loop back in time and change the course of events. However, there's a catch. This creates some mind-boggling paradoxes. For example, if you traveled to the past and prevented your own birth, would that mean you could never have traveled to the past in the first place? This paradox, known as the grandfather paradox, raises significant questions about how time would behave in a universe where backward time travel is possible. Some theories suggest that time travel could be self-consistent, meaning events in the past could only unfold in a way that prevents paradoxes. This is called the Novikov self-consistency principle, which proposes that if you travel back in time, any actions you take would be part of a consistent timeline that avoids contradictions. But even this principle is speculative and has not been proven. Challenges of time travel. Using black holes. While time travel via black holes is an exciting concept, there are many challenges that make it seem almost impossible with current technology. First, there's the issue of spaghettification. As you approach a black hole, the difference in gravitational forces between your head and your feet becomes extreme, stretching and pulling you apart. This process, called spaghettification, would likely destroy any spacecraft or person that gets too close to the black hole. Second, even if wormholes exist, they are thought to be incredibly unstable. Without exotic matter to keep them open, these wormholes would collapse before anything could pass through. The theoretical concept of stable wormholes remains a significant challenge in physics. Lastly, the energy required to manipulate spacetime on a scale large enough to create or stabilize a wormhole would be astronomical. The technology and energy resources needed to achieve this are far beyond our current capabilities. Conclusion. Time travel using black holes is a fascinating yet highly speculative idea. While the theories are rooted in real physics, especially the concept of time dilation and the potential existence of wormholes, we are still far from being able to manipulate spacetime in a way that would allow for time travel. The dangers of spaghettification, the instability of wormholes, and the need for exotic matter are just a few of the hurdles that stand in the way. Nonetheless, black holes continue to captivate the imaginations of scientists and dreamers alike. As we continue to learn more about these cosmic giants, who knows what future breakthroughs might bring? Maybe one day, we'll unlock the secrets of black holes and time travel, opening up a whole new chapter in our understanding of the universe. Thank you for watching. If you enjoyed this exploration of black holes and time travel, be sure to like, comment and subscribe for more fascinating insights into the mysteries of space and time. Until next time.